What are the problems with MRP systems? Number one is integrity of the data. If there are any errors in the inventory data, the bill of materials, commonly referred to as BOM data, or the master production schedule, then the output data will also be incorrect. GIGO, or garbage in, garbage out. Data integrity is also affected by the inaccurate cycle count adjustments. Mistakes in receiving input and shipping output, scrap not reported, waste damage, box count errors, supplier container count errors, production reporting errors, and system issues. Many of these type of errors can be minimized by implementing pull systems and using barcode scanning. Most vendors in this type of system recommend at least 99% data integrity for the system to give useful results. Systems require that the user specify how long it will take a factory to make a product from its component parts, assuming they are all available. Additionally, the system design also assumes that this lead time in manufacturing will be the same each time the item is made, without regard to quantity being made or other items being made simultaneously in the factory. A manufacturer may have factories in different cities or even countries. It is not good for an MRP system to say that we do not need to order some material because we have plenty of it thousands of miles away. The overall ERP system needs to be able to organize inventory and needs by individual factory and intercommunicate the needs in order to enable each factory to redistribute components to serve the overall enterprise. This means that other systems in the enterprise need to work properly, both before implementing an MRP system and in the future. For example, systems like variety reduction and engineering, which makes sure that products comes out right first time without defects, must be in place. Production may be in progress for some part whose design is changed, with customers' orders in the system for both the old design and the new one concurrently. The overall ERP system needs to have a system of coding parts such that the MRP will correctly calculate needs and tracking for both versions. Parts must be booked into and out of stores more regularly than the MRP calculations take place. Note these other systems can well be manual systems, but must interface to the MRP. For example, a walk-around stock intake done just prior to the MRP calculation can be practical solution for a small inventory, especially if it is an open store. The other major drawback of MRP is that it fails to account for capacity in all calculations. This means it will give results that are impossible to implement due to manpower, machine, or supplier capacity constraints. However, this is largely dealt with by MRP2. Generally, MRP2 refers to a system with integrated financials. An MRP2 system can include finite or infinite capacity planning. Nevertheless, to be considered a true MRP2 system must also include financials. In the MRP2 or MRP2 concept, fluctuations in forecast data are taken into account by including simulation of the master production schedule, thus creating a long-term control. A more general feature of MRP2 is its extension to purchasing, to marketing, and to finance, integration of all the functions of the company. ERP has been the next step. Poor inventory management. Poor inventory management. Close control over inventory is vital for profitability and efficiency. Just in time. Manufacturing has made good control processes even more important. If you don't carry large stocks, you need to know what you have and be able to reorder it as and when needed. But the benefits of effective inventory control extend beyond pure production efficiencies and include aspects such as minimizing wastage and spending, both of which can impact on the bottom line. Modern programs can deliver these efficiencies, but they have to be designed for the job. Resource planning software is not an install and forget solution. And if you don't keep it updated, the resulting MRP issues will cause even more manufacturing problems in the future. Inadequate quality control. Customers have always had the ability to be unforgiving, but never more so than in today's climate of instant feedback and social sharing. In this climate, manufacturers need to ensure that quality control is designed in and built in from start to finish. Though this is not inherently easy to achieve, it's essential to have systems capable of preempting or responding to manufacturing problems quickly and efficiently. Here again, efficient resource planning is going to help, particularly with error stemming from communication issues or recurring causes, so that the business can address and deal with them quickly. Supply chain problems. There was a time when manufacturers sourced almost everything they needed, whether raw materials or components, from local suppliers. However, in the modern world, it's possible and often beneficial to source further afield. Examples for lower cost, and there can, however, be multiple problems with this global supply chain, including price fluctuations, reliability issues, and quality control, among others. You need modern control to monitor suppliers, receive updates around the clock, and react instantly if and when problems come. Today's manufacturing ERP programs provide the data integration and automation to enable the decision to be made quickly and efficiently. Data management failures. Business generate masses of data, but all too often this invaluable resource is used ineffectively or not at all. Information about everything from raw material pricing to supplier performance is now readily available. The opportunity to gain insights from such data could, however, be wasted, and any benefits from these insights lost if the business has the MRP issues of having limited or outdated IT systems. However, data When correctly collated and analyzed by modern fit-to-purpose ERP software, can provide manufacturers with real and measurable advantages. Ineffective process management. As the saying has it, constant change is here to stay. And the pace of change now seems to increase every year. The 21st century has many drivers for such change. These include the speed with which information is exchanged, the increasing generation of data, widening customer expectation, and the relative ease with which new products can be introduced into the market. To cope with these factors, it's essential for manufacturers to have clear control of their processes. Without this, isolated quick fixes to respond to changing demands can go on to cause costly manufacturing problems. That makes investment in the right kind of manufacturing ERP systems business critical, because it's only with the right system that processes can remain managed yet adaptable to meet new challenges and evolving environments. Finally, we all need to be aware of the importance and inevitability, inevitability of being more connected. A business environment where everything is linked seamlessly together calls for software with a future, not luck in the past. The days of relying on homemade spreadsheets or software fixes are disappearing, as even small manufacturers are choosing today's proven ERP products to be successful. As importantly, companies are seeking trusted IT partners to help them thrive and survive in the changing manufacturing industry into the future. What are the solutions to data integrity issues? Number one is bill of material. The best practice is to physically verify the bill of material either at the production site or by disassembling the product. Cycle count. The best practice is to determine why a cycle count that increases or decreases inventory has occurred. Find the root cause and correct the problem from occurring again. Scrap reporting. This can be the most difficult area to maintain with any integrity. Start with isolating the scrap by providing a scrap bins at the production site and then record the scrap from the bins on a daily basis. One benefit of reviewing the scrap on site is that the engineering group can take preventive action. Receiving errors. Manual systems of recording what has been received are error prone. The best practice is to implement the system of receiving by ASN from the supplier. The supplier sends an ASN or advance shipping notification. When the components are received into the facility, the is processed and then company labels are created for each line item. The labels are affixed to each container and then scanned into the MRP system. Extra labels reveal a shortage from the shipment, and too few labels reveal an overshipment. Some companies pay for ASN by reducing the time in processing accounts payable. And shipping errors. The container labels are printed from the shipper. The labels are affixed to the containers in a staging area or when they are loaded on the transport. Production reporting. The best practice is to use barcode scanning to enter production into inventory. A product that is rejected should be moved to an MRB or the Material Review Board location. Containers that require sorting need to be received in reverse. Replenishment. The best replenishment practice is replacement using barcode scanning or via pull system. Depending upon the complexity of the product planners, and can actually order materials using scanning with a minimum or maximum system. And mark your entire laboratory workflow from sample receipt to release of result mapping. The entire laboratory workflow can lead to significant consolidation. Taking all related operations into consolidation, simplify your workflow to mitigate data integrity risk and make validation easier. Drop spreadsheets for data storage. Data integrity relies on having reliable master data or a single source used across systems to use when discrepancies are detected. Spreadsheets should never be used for this kind of data storage as they offer no protection against data corruption and no multi-user or validation capabilities. With the click of a button or copying of wrong information, metadata can be lost in an instant, creating an enormous data integrity problem. Automate data capture. Changes in the ways laboratories collect, store, and transport data are forcing changes to the ways laboratories operate. Sample analysis is one activity in particular where data integrity issues often arise. Train for data and process management. Training personnel in proper data management must go beyond documentation. Practices to cover why processes are conducted the way they are, they should extend to every process on the manufacturing floor. Training has to address the how and the why is a particular ingredient or component added or installed during this phase of production. How does it affect the product? With a depth of knowledge into not only what needs to be done, but why it needs to be done that way. Operators naturally become more conscious about the decisions they make in every dimensions of work.